Okay, today is January 12th, 2012. We're going to combine lesson 8.1 and 8.2. You guys have written down the definitions for many of these. We're going to talk about them and apply some of the formulas on the side here to these, so we know when to use which formula with which type of interest. So, simple interest. Simple interest means it is interest earned on the original amount invested, okay? So, let's say, I'm sure some of you guys have a job. Okay, so, somebody here has a savings account, okay? And he has a chance to put it in two different types of bank accounts, okay? There's a savings account that's going to give him simple interest, and there's a savings account that is going to give him compound interest. Now, he has $4,000 to invest, which is a very nice, hefty amount, okay? So, we have $4,000 to invest. His simple interest, the first bank account, so we're going to say option A. It's a simple interest. We'll call it SI for simple interest. And we're going to say he's going to earn if you have $4,000, a bank might give you something like 2-3%. So we're going to say he's going to earn 2% on a simple interest account, and it is 2% annually. Anyone know what annually means? Once a year. Once a year. Every year he's going to get 2%. Now his option B is to invest in a compounding interest bank account. Same idea, 2% annually. Same thing. It's going to be annually. Okay, so we're going to compare the difference between these two. So right now we're comparing simple interest account to a compound interest account. One of the first things we can do is we can actually calculate the amount of interest this person's going to earn. And we're going to have to do that for this question. So, we have a formula on the side. Calculating interest. We're going to take this I equals PRT. We're going to have to define what some of these things stand for. Our I is going to be the interest, okay? Our P is going to be the principal. R is your interest rate, and T is the amount of time it's invested for. This is for a simple interest, okay? Simple interest account, this will calculate our interest. So, this person, let's say for our simple interest account, A, we're going to calculate how much interest they're going to earn in total. So their interest in total, their principal is the $4,000. So our P is equal to $4,000. That's how much money they have to invest. So they're investing $4,000. The R is the actual interest rate. Now the interest rate is 2%. What number do I use to represent 2%? That's right, I don't just put in the number 2. I write it as a decimal. So 2% as a decimal is 0.02. Okay? And T, we're just going to assume, let's say for the first example, that is over the course of 1 year. Okay? So this person only invests this money in a bank account for 1 year, and he's getting interest annually, so he's going to get that interest just once. So the T for time is going to be 1. When we go to calculate this, it's pretty straightforward. It's 4,000 times 1, which will change nothing, times 0.02. This is the amount of interest they earn in the account. So at the end of the year, this person gets $80. It doesn't mean there's only $80 in the account. Yeah, that's right. If we want to figure out how much is going to be in his account now, we're going to add the original amount. So we add the principal plus the interest to figure out their amount. Okay? The principal was $4,000, and the interest earned was $80. So in their account, they had $4,080. Okay? Okay. So in our option A, after 1 year of simple interest, this person earns an extra $80. Let's look at option B. Option B, exact same idea. We're going to use that formula. Their interest earned is equal to the principal, which is formula. For our compound interest, we're going to be using this formula down here. Okay? A is equal to P 1 plus I power of n. Okay? We're going to talk about what all those variables are. This is going to give us the amount at the end, not just the interest. Okay? So the amount at the end of this one, P equals 1 plus I n. Again, P is still our $4,000. Our principal is still $4,000. 1. Now I want to show you guys something quick. I is a calculation. R actually stands for the interest rate. You actually have to calculate I. Okay? So I is your interest rate divided by compounding periods. Now in this one we said that the interest rate was annually and it compounds annually. So we would normally divide I is equal to R divided by C. Our interest rate is still 2%, so 0.02. And our compounding is still 1, so I is still 0.02. Okay? It didn't really change. It stays the same because our compounding periods haven't built up yet. We're going to get into when they do. 0.02. N is the number of compounding periods. We already figured that out. There's only one compounding period. So we're going to put this to the power of 1. Yep. So we get 4,000 times, this is 1.02. 1.02 to the power of 1 is 1.02. I'll show you quickly. The power of 1. Same number times 4,000. Anyone guess what we get? 480. Was there any difference in these accounts after 1 year? There's no difference in these accounts after 1 year. Okay? After 1 year, it did not matter which account he chose. He got the same amount. Now, we're going to talk about investing for 2 years. I'm going to show you the difference here. So let's go back to A again. This time we'll do it in blue. So black was for 1 year. So we'll say this is 1 year. 2 years in this bank account. Now, the way simple interest works, this is very important. This is why I want you guys to define it. Simple interest, the interest you earn is only on the original amount of money you invested. It does not matter how much money is in your bank account come the second year. So, in year 2, how much money are we starting with in our bank account? We're starting with $4,080, right? We earned $80 in interest after the first year. But because it's a simple interest account, they're just going to get how much interest once again? We calculated earlier. How much interest did they get before in the simple interest? 80. Okay? So a simple interest account takes the same amount each year and adds that to the account. Okay? The interest rate doesn't change. It's only calculated on the original amount. So it's very simple to calculate it for the second year. We just add 80. We get 4,160. I don't need a bracket there. Now, the hard one is compound interest over 2 years. You've already calculated it? Wait till I explain it. Okay. Now we're going to go back to that formula for the amount. Okay? A is equal to P, 1 plus I to the power of n. So, our principal is the original principal. Okay? We don't go and do 480 like we did in the simple interest account. We still plug in the 4,000 what we started with. Our I is still 0.02. The only thing that's changed over the course of 2 years is the number of compounding periods. N is technically equal to the number of years times the number of compounding periods, C. So YR times C. Now we're investing for 2 years, and it's compounded once a year. So N is now the number 2. Okay? This is being compounded over 2 years. So we now put this to the power of 2. We get 4,000 times 1.02 to the power of 2. 1.02 to the power of 2. So we get a new number. And once we multiply by 4,000, what do we get, Chris? There we go. $4,161.60. Now, Clearly not a huge difference, okay? But if you're trying to maximize money, you clearly want to go with the compounding investment. What's happening with the compounding investment is it's earning interest on the new amount every year. Where with the simple interest, they just gave you the same interest rate every single year. You would get $80 every year, even if you left it in for 100 years. If you had left this in for 100 years, okay, I'm just going to quickly recalculate that. 1.02 to the power of 100 times 4,000. You would have ended up with $28,978. Much better to compound. Okay? So anytime you get an example of a bank account, if they're willing to give you compounding interest, you're going to end up earning a lot more money depending on the number of. Okay, our second example, we're going to take the same amount of money. There you go. Our second, no, why does I say example 4? Example 2. Same amount of money. So, a principal of $4,000. Same interest rate. We're going to say interest rate is 2% annually, which almost any interest rate you'll ever get from a bank is an annual interest rate. What's going to vary is the compounding periods. Okay? So we're going to say in bank account A, again, it's a compounding interest at 2% a year. But we're going to say compounding. Now what we'll say semi-annually, because we just did an annually one, so you already know the amounts for that. And in the other one, we're going to compound it quarterly. The second bank account is a compounding interest account, 2% a year again. But in this one, you're going to compound quarterly. And I want to ask you guys if you know the difference here. Quarterly. Yeah, how many quarters are there in a year? Same as there is in football and basketball. There's 4 quarters in a year. So in this one, that means C will be equal to the number 4. What about semi-annually? You want to know how often semi-annually compounds? Twice. Semi means 2, okay? So our compounding periods are twice a year. Now what that means is you do not earn 2% at each compounding part, okay? They divide the amount up. So a couple things we need to do with these two accounts. We're going to take the first account, and this is where we have to refer it back to these little definitions I've given you guys, okay? N and I, you actually have to calculate those two numbers. So our interest rate, A, is equal to P 1 plus I to the power of N. What's important with these? Okay, so what's important is I and N aren't straightforward. We actually have to calculate both of those. N is equal to the number of years we put money in for times the compounding periods. Both of these have different compounding periods. And I is equal to R, which is our actual interest rate. That's the 2%. I'll change the colors. I is equal to our actual interest rate divided by the compounding period. Now, we're going to start the first one. We're going to do it over the course of 1 year again, just so we can refer to our last question and see what the difference is. Okay? So in our first question, A, our principal, still the exact same amount. P is $4,000. Our I, we have to calculate. In our first example, A, we're compounding twice a year. So that means I is equal to 2% is 0.02 divided by 2. So our new I, 0.02 divided by 2, will be 0.01. There we go. So our new I is 0.01, okay? So what that means is we're splitting up the interest plus 0.01. Our N is the number of years, which is 1. And our compounding periods were 2. So it's going to compound twice in a year. So I want to talk about this idea of what we just did here. A lot of times this is what's confusing. Our interest rate was 2%, but because they're compounding twice a year, they split that percentage. They split it evenly into the number of compounding periods. So if we're getting 2% and we're compounding twice a year, we're going to get 1% each compounding period. So that means if I put it in January, 6 months down the road, I get 1%, and then 6 months down the road again, I get another 1% on what's in that account. Okay? So our compounding periods, there's twice in a year, but the amount we compound in each of those periods is actually 1%. Okay? So it still works out much nicer, this one, because we're compounding more often. So $4,000 plus times 1.01, that needs to be a bracket, to the power of 2. 1.01 to the power of 2 times 4,000. We end up with $4,080.40. Okay. So really, from what we did before, we've only really earned another 40 cents when we compound twice a year. When we have that second bank account, we're going to do the same idea. 4,000, 1 plus. Now our I and our N is going to change again. The actual interest is still 0.2, but because it's quarterly, we're breaking up 2% into 4 pieces. So off the top of their head, does anyone know what percent we're going to get each compounding period? We divide, I put times, sorry. 0.02 divided by 4. 0.005. Anyone know what that means? What is that as a percentage? That's 0.5%, which makes sense. If I add 0.5 plus 0.5 plus 0.5 plus 0.5, that gives me my 2% over the course of a year. It's just that it's being compounded more often, so we're earning a little more money each period. Yeah. So we have a new I, and our N is the same thing. N is the number of years. We're still only using 1 year, but we're using 4 compounding periods. So N stands for the number of compounding periods, which is 4. So we plug these numbers in. We get 0.005 to the power of 4. 4,000, 1.005 to the power of 4. We plug that in. 1.005 power of 4 times 4,000. And we got 60 cents instead. So $4,080.60. So the difference between the two compounding periods is 20 cents. Not much over the course of a year, but as these things start to add up and the amounts you put in add up, every compounding period is going to earn you more and more interest. And it's going to become a larger and larger gap depending on the number of years you're invested for. Just so we can compare to the other page, we're going to do the same stuff, just over 2 years. We're going to use the same interest rate. 1 plus. Our I is going to be different. The I is going to be different because we have 0.02 divided by 2. We're still doing 0.01. So our interest rate is still 0.01. What's going to happen is our N is going to change. The number of years, remember it's years times compounding period. We're still using that semi-annual example, but this time it's over the course of 2 years. So the number of compounding periods is now 4. 0.1 to the power of 4. So it's compounding a little more often now. Okay? Before, if it was only compounding once a year, over 2 years it only compounds twice. Since we're compounding semi-annually, we're compounding 4 times over that timeline. So $4,000, 1.01, because we split the 2% into the 2 compounding periods a year, it happens 4 times. 1.02 to the power of 4 times 4,000. $4,162.41. And in the second example, where it was quarterly, I'm going to quickly do this one just so we can compare. 1 plus. Our I is 0.02 divided by 4. We already know what it is, 0.005. Our N is going to be a little different. Oops. N is the number of years. So it's 2 years, compounded 4 times a year. N is now 8. So we're doing an exponent of 8, and why this is important, we just did exponents. You can see how much when exponents jump, these numbers get much larger, much quicker. 4,000, 1.005 to the power of 8. 1.005 power of 8 times 4,000. $4,162.82. So let's do it. Oh, if we round up, yeah, 83. Okay. So if we take a look at the differences between these, a simple interest formula, we're only earning $80 every time. So we're up to $160 interest over 2 years. When it was compounded once a year, we had $161.60. When it's compounded twice a year, let's just do this. We earned $162.41 in interest. And when it's compounded 4 times a year,